Welcome to Module 5, Lecture 5B, Livestock Management, Rotational Grazing, from the web-based course, Pine Silvopasture in the Southeast. High impact areas associated with traditional grazing can have detrimental impacts on tree growth and survival in a silvopasture system and lead to soil erosion. For a well-managed silvopasture, rotational grazing is recommended. Rotational grazing involves using several pastures or paddocks, with one being grazed while the others recuperate. A proper rotational grazing system is designed so that the nutritional needs of livestock can be met efficiently, forage yield and quality as well as pasture persistence can be optimized, and economic profit can be realized through improved efficiency and productivity of livestock. Traditional stocking systems involve continuously grazing animals on a single pasture throughout the entire grazing season. Rotational grazing yields higher quality pastures and favors the sustainable production of legumes and other desirable forage species. Moving to an improved grazing system will improve yield per acre beyond that of continuous grazing. Rotational grazing allows the producer to adjust stocking rates to the changing growth rates of forage throughout the season. Continuous grazing, on the other hand, does not allow for pasture rest periods that allow forage regrowth to occur. Continuous grazing can therefore lead to overgrazing during slow forage growth periods, which reduces the potential yield of the pasture. Rotational grazing systems have a number of advantages as well as some drawbacks. Rotational grazing can reduce supplemental feeding and pasture waste. It can improve forage composition and yield improves animal waste distribution. It also minimizes daily fluctuations in intake and quality feed and allocates pasture to animals more efficiently based on their nutritional needs. It is important to realize that a well-implemented rotational grazing system typically entails more management, time, and labor than continuous grazing. It also requires more fencing and water facilities and requires a good understanding of forage growth cycles and regrowth. With more cattle in smaller areas, rotational grazing can result in mud and soil compaction, so the operation must be monitored more closely. Managers can use a versatile fencing strategy to utilize pasture blocks or paddocks more efficiently to control pasture allocation. This allows animals to be rotated to new grazing areas before they graze the new regrowth of forage plants, allowing a sufficient recovery period for forages. Paddocks should be laid out as squarely as possible and on similar soil types. Square paddocks require less fencing to enclose a given area and reduce distances to water. Square paddocks also generally result in more even manure distribution than paddocks of other shapes. However, adjustments must be made for the soil productivity and the lay of the land. A rule of thumb to follow is that rectangular paddocks should not be more than 4 times as long as they are wide. There are many paddock design options for rotational grazing. A producer new to intensive rotational grazing may want to start with just 4 or 5 paddocks and then move up to 8 or 10. Watering structures can be arranged to best facilitate access for livestock. There really is no blueprint or single model to follow in setting up a grazing system. It's best to start at a level you're most comfortable with. If you have streams that run through your property and pasture units, landowners can receive cost share funds to fence stream areas from livestock grazing. In many areas, this is a very economical alternative use for the protection of water quality. However, streams on properties can be integrated into smaller paddocks for short duration grazing while still protecting the stream and water quality. The location of gates in a rotational system is very important to help facilitate the movement of livestock from one paddock to another. You will also need to take into consideration the placement and alignment of temporary lanes and alleyways to move cattle easily where you need them to be. Temporary lanes can be easily established using polywire or polytape, which can be moved throughout your pasture system. The picture in this slide is an example of a landowner's rotational grazing design. You can experiment with different plans and designs using aerial property photos. For most typical beef cattle operations in the southeast, 5 to 10 paddocks may be sufficient. This allows paddocks to be grazed for 3 to 7 days and then rested for a month. Aerial photographs are available at the local Farm Service Agency office. A well-designed planning map should be a basic grazing system with water in each field. It should be divided based on productivity and have enough fields to begin rotational grazing. In summary, a rotational grazing system with paddocks gives the manager greater control. Designing a pasture system involves many decisions, including the number and size of paddocks, the location of water sources, and lane placement and livestock flow. However, the most important factor in developing a rotational grazing system is to develop one that's right for the landowner, the farm's resources, and the land's capabilities. Welcome to Module 5, Lecture 5A, Livestock Management, Fencing and Watering, from the web-based course, Pine Silvopasture in the Southeast. Proper fencing is a necessary component to reduce overgrazing in an efficient rotational grazing system. We'll cover rotational grazing in more detail in Lecture 5B. Fencing plans need to follow NRCS specifications, extension publications, or guides published by reputable fencing companies for requirements to meet local environmental conditions and special livestock considerations. High tensile wire is recommended when using energized fences for border areas and is also used for cross fencing. Larger diameter wires create less resistance and therefore better current flow. Therefore, it is recommended to use at least one 12.5-inch gauge double insulated cable as your lead out to reduce resistance. The number of strands depends on the type of livestock being grazed. Generally, a minimum of 4 to 6 strands is recommended for border fencing, and 1 to 3 strands is recommended for cross-fencing cattle. However, the number of strands and strand arrangement may be different for other livestock such as sheep or goats. Energized fences can be easily installed and provide a psychological deterrent when the fence carries a proper current. AC powered units are the best choice for energizing a fence if 220 or 110 volt power is available. Solar recharging battery systems can also be used and installed easily on site. A properly installed energizer should produce 1 joule per mile of fence. To assure effective operation, the energized fence needs to be properly grounded with a minimum of 3 feet of ground rod per joule output. This is typically provided by 3 96-inch ground rods or other configurations in shallow soils placed at least 10 feet apart. They should also be protected from lightning by installing a surge protector at the power source, a lightning choke at the fence, and an additional ground rod every 3,000 feet of fence. Polywire or polytape is another tool, another fencing type that can be used for temporary or portable cross fencing to create smaller paddocks for intensive grazing or to allocate stockpiled pastures for winter grazing. Electrified polytape is very visible and easy to use for dividing a pasture. Polytape actually flutters in the wind, making it more visible and serving as a deterrent to livestock as well. Polywire and polytape fences are also easy to move. Paddocks can be easily established with energized polywire fencing and moved as needed when cattle are accustomed to the fencing. This enhances the manager's ability to more easily create grazing areas, move cattle from paddock to paddock, and provide optimum forage recovery periods. There are also a few simple tools that are extremely useful when using energized fencing as part of the grazing system. The tool known as a spinner. Before installing high tensile wire, acquire a spinner to reel out the wire without adding twists, which is a frustrating chore for anyone who's had to get rid of kinks or twists while trying to set up a fence. Inline switches are also wise investments to locate faults in fenced areas. By strategically locating switches, a landowner can save miles of walking when tracing electrical current using a voltmeter. Bungee gates are also easy to set up and make moving between paddocks much easier. Animals acquire water through drinking and from the moisture in the forage that they eat. As air temperature increases, water requirements also increase. This becomes especially critical as air temperatures exceed 77 degrees Fahrenheit. The need for available drinking water is compounded because forages become drier at higher temperatures. At 90 degrees Fahrenheit, a 600-pound growing steer needs about 13 gallons of water per day. At 60 degrees, that need falls to around 8 gallons per day. One distinct advantage of a silvopasture system is that shade is distributed throughout the pasture and greatly reduces high temperature stress on livestock. A water source should be available within 600 to 800 feet of cattle, but avoid placing portable water tanks in the center of a paddock system. When forage resources are far from water supply, cattle move back and forth through the water as a herd. This limits the number of times per day the animals water and the total consumption of both water and forage. And a centrally located water source can result in compaction and erosion immediately surrounding the watering site. Consider using portable water tanks that can be moved easily between paddocks. If installing permanent tanks, consider concrete tanks and tank covers. Heavy equipment tires are also a popular and durable choice. Cleaning the inside of tanks may be necessary to remove calcium residues, algae, and other junk. Water supply options for silvopasture also can include wells, creeks, ponds, spring developments, and even municipal or rural water systems. Ponds can also provide a good reliable source of drinking water for livestock and wildlife, as well as providing other benefits. The pond's watershed should be protected from erosion and excess agricultural chemical or nutrient runoff so it can provide good clean water. This is not a problem in a well-managed silvopasture system. When water is close to forage, the herd's social structure keeps animals watering more frequently as individuals. This keeps the herd dispersed throughout the paddock and results in a greater portion of time spent grazing. Traveling long distances to water tends to promote overgrazing in areas closest to water and underutilization of forages which are located at greater distances from the water source. Overgrazing causes excessive compaction of the soil and has negative impacts on forage and tree production in a silvopasture system. In summary, over the years there have been many advances in livestock watering systems design and fencing materials that have made rotational grazing both convenient and more affordable. However, there are some special considerations that must be given to water and fencing in a silvopasture system to maintain productive pastures and to optimize livestock health. Welcome to Module 4, Lecture 4B, Canopy Management and Thinning, from the web-based course, Pine Silvopasture in the Southeast. Canopy management is an essential element of maintaining a productive silvopasture. While cool season grasses can thrive at higher canopy densities, i.e. more shade, warm season grasses require more sunlight. Even forage in silvopasture alleys can be affected by shade produced from the tree rows. Therefore, pruning and thinning play an important role in the production of high-quality forage. As the trees planted in a silvopasture system begin to grow, their canopies produce more shade. While pruning trees helps to open up the canopy, thinning is also necessary to maintain forage production and develop higher-quality timber. A 25% to 60% canopy is needed to sustain warm to cool season grasses. While some forage species will thrive in full sunlight, studies have shown that shade can actually increase the quality of many forages. A spherical densiometer is a tool used to measure and calculate canopy density, which is more accurate than eyeballing a site. The instrument has a convex mirror with intersecting lines that form a 24-point grid. Because the mirror is convex, it reflects the canopy overhead. To use a densiometer, hold it level in front of the body. You can count and record the number of grid squares that are more than 3/4 filled and divide this number by 24, which is the total number of grid squares, to calculate the percent coverage. Or you can multiply the number of empty squares, those less than 1/4 filled, by 4.17 and subtract this number from 100 to give you the percentage of canopy cover. Multiple readings taken through random places throughout the stand can be averaged to get a canopy density percentage for the site or the particular plots you are estimating. Planting arrangement plus tree growth dictates the thinning schedule. When canopy closure begins to reach 50% per your densiometer readings, a thinning should be considered. Pines on good sites can typically be thinned when they reach 12 to 15 years. However, this depends on a number of factors: how the silvopasture was initially established, or if it was converted from an existing plantation, among other things. If trees were planted initially at 150 to 200 trees per acre, only one thinning may be necessary well into the rotation, perhaps at the 20-year mark, to remove poles or saw or veneer quality logs and provide additional space for 10 more years of growth for the high quality saw logs that are left. Thinning may be needed every 5 to 7 years to remove the canopy, improve tree quality, and sustain forage production. If you are planning on converting an existing forest or pine plantation to a silvopasture, trees may be thinned to an optimal density for forage production. Trees should be selected and removed to open the canopy to at least 30 to 35% to establish forage. If the stand is under-thinned during this conversion, it may require an additional thinning within 5 years to sustain forages that may get shaded out as the canopy begins to close again. After any major pruning or thinning operation, large amounts of slash and debris may build up. A prescribed burn after a thinning is an efficient way to clean up debris and also to remove any competition or undesirable weed species that may have established themselves on the site. Forage alleys, especially in silvopasture systems that were originally established in open pastures, will eventually serve as the access roads for thinning and harvesting, which reduces the need for additional clearing and road construction for logging operations. In summary, canopy management is critical for successful forage growth in a silvopasture. Well-executed pruning and thinning will create high-quality trees for timber as well as high-quality forage for livestock. Having the proper equipment for these tasks is imperative. If you have questions, you may contact your county or district forestry office or a private forestry consultant for recommendations on pre-commercial thinning and marketing your timber.